Hey everyone, okay, how's it going? Welcome back, and before I get started, let me just say that I've already made this video on my phone. This is mine. I kind of fixed it, like, if you drop a phone in water, um, if you drop a phone in water, you can disassemble it and put the SIM card and the memory card and the battery and everything in some rice, and the rice actually soaks up the moisture, so that's kind of handy. But it's still having some troubles with YouTube and uploading, so I'm going to use my mom's phone again, this time with her permission, more or less. So anyway, the video is titled Why Time Doesn't Exist or Might Not Exist, but I'm also going to get into time travel and giant beams of light that will disintegrate Earth and all the solar system within a few millionths of a second. So anyway, why time might not exist. All of Newton's laws, relativity, the quantum mechanics, they all function independently without time, and then the past is probably just inside a person's mind, just a memory, and the future is just an anticipation. There's only one strong argument that does say time would exist, and that is the theory of thermodynamics. I'm not going to get into that because it'll be kind of off topic. But anyway, Stephen Hawking once believed that if the universe started to contract, which it will, time would run backwards, but he later changed his mind as if to demonstrate the process. Now, if that were to happen, we would see it. We would see people walking backwards and whatnot. We would see it and notice that something was amiss. Actually, we would not, because if you think about it, if that were to happen, our own mental process would run backwards as well, so we wouldn't notice a thing. Now, if time's a real state of existence, wouldn't time travel be a valid item as well? Not really. Not many scientists take the idea seriously. So one of the arguments that people have, if time travel is possible, where is everyone? Where is people from the future? Why aren't they come back here to say, hey, we're from the future? Well, you can actually never travel in time to the past. We know how to travel in time to the future, but you can't do it in the past. So people in the future can travel in time to the future, but the past will never happen. There are three ways one can travel to the future, travel through time. One is not a very well-known thing, but not a very well-known theory. The other two are a little well-known, but we'll get into that later. The first one is when you're near a large object, the gravitational pull can actually slow time a little bit. So if you were vacationing in Egypt and you're hanging out near the pyramids, time near the pyramids is actually slowed by 1.2 billionths of a second than you would be if you were on the streets away from the pyramid. It's not noticeable for the human, absolutely not, but it's still there. And whereas if you're on a space shuttle on Earth, it's a little bit bigger, but still not too noticeable. And if you wanted to travel in time using the gravitational pull theory thing, you'd have to travel to the center. The best way you could do it is traveling to the center of the galaxy. What's in the center of the galaxy? Well, this is a black hole. Not just any black hole, a supermassive black hole. Scientists, including myself, believe that in the center of a galaxy is a black hole, a supermassive black hole. As the names imply, a supermassive black hole is much more super and massive than a normal black hole. So, a black hole, supermassive black hole, this one in the center weighs as much as 3 billion suns, which is a lot. So, if you wanted to travel in time, you could take a spaceship and drive it. It'd take a while to get to the center, but you'd do it. And you'd have to build one that has enough fuel to get there, and you'd also have to build one that's strong enough to resist the gravitational pull, because not even light can escape these. So they'd have to be a pretty strong ship. And if you managed to do that, and you drove around, like, if you circled this supermassive black hole for 4 years, and you traveled back to Earth, 8 years will have passed on Earth. So you would have slowed time down by half. This isn't very practical, but it's just a theory. I'm just talking. Now the second one is the best well known. It's light speed. Well, actually, you don't need to. You can't travel. You can't. The science fiction movies just love to show the starships. I'm kind of talking about Star Wars right now. Starships accelerating to light speed to get through this space, get through to different areas. One, even at light speed, it would take years to get most places. Even in our own galaxy, it would take years. So even at light speed, and then here's another thing. It's called mass acceleration. What happens is when a starship were to take off, it'd be just fine. But if it were 99%, 98% to the speed of light, it would be 7 times heavier than it was. And then it would be heavier more than the galaxy, and then it would be heavier than itself. This acceleration actually causes this spaceship to become heavy. So if you were to actually reach light speed, the ship would be so heavy that no kind of energy known to man would be able to do to power this super extremely heavy ship. It's heavier than the whole galaxy, the universe. I mean, that's not possible. But you don't really need to travel at exactly light speed. You can just travel at 98 or 99% light speed and you'll be just fine. It'll do everything that light speed travel is supposed to do. But you need to have a ship that has a staggering amount of fuel. If you manage that, then go ahead, you can do that. Once again, it takes years and years to reach 98 or 99% light speed to travel in time. And then when you travel back, Earth will be 4.5 billion years will have passed at Earth, and you're just a germ to the evolutionary process that's happened. So that's, once again, that's not very practical. But number 3 is as well known. It's the wormhole. But little do you know, in a plane smaller even than atoms, there are wormholes. Wormholes do exist. You don't make wormholes. They're already there. They travel to the future. On all of these that I just mentioned, they travel in the future. So, a wormhole. In the tip of my finger, there's quintillions of these wormholes on this plane. The real problem that you have to take is to capture and enlarge these wormholes to get something through there. And then it's probably not the wisest of ideas because the person something might happen. So time travel really isn't that good of an idea. Nothing is very practical. Unless you can discover something else, fine, great. But time travel is way out of our hands, and time travel could mess up the fabric of time. And time travel actually isn't a very good idea. So, I forgot what I was going to say next. Gotta check my notes. I was going to talk about... Oh, yes. So, regardless of whether time exists or not, its passage certainly varies in perception, and definitely alters and acts differently. So, actually, there kind of is a way you can travel into the past. When you look up at the night sky, you are seeing into the past. How? So, say one of the stars you were looking at was 6,000. If it was that close, it'd probably be much bigger than it looks. But for the sake of simplicity, I say 6,000 light years away. In each light year is 6 trillion miles. So, however many light years it has is how many years it takes for the light to reach Earth. Even at light speed, it still takes a long time. So if this 6,000 light year away star were to blow up in a supernova, our sun isn't going to go into a supernova. It's not very big. It's actually a very tiny star. It's one of the smallest stars there is. It's probably like third from smallest, and so our sun sucks. Like, I'm grateful that it's here, because we wouldn't be alive if it weren't there, but it's a pretty small star. So if this star were to explode in a supernova, we wouldn't notice the supernova explosion until 6,000 years. That's how many light years away. But in all reality, 6 million light years is more realistic, so we'll just go with that. So this is more about time travel than why time doesn't exist, but in the next video I'm going to upload, which is actually going to be in a while because I'm pretty bored today, it's actually going to be not really scientific, but it's actually a drawing tutorial. It's actually going to explain how to draw some sort of explosion, a manga style explosion, but you'll just have to watch it. So I'll see you later. If you have any ideas on how I can make these videos better, go right ahead, because I do tell, because I'd like to make my videos better. Everyone does. And if you have any ideas for other videos, something about science or computers or something nerdy, because it's my username, once again, do tell, because I'd like to know. I kind of like to serve the public, because apparently those videos, if people do that, get more popular. So anyway, I'll see you later. Watch my next videos. Like and comment and subscribe, and I will see you later.